Can anyone explain about the history of chromatography? Make it fast. Akashna.
Good morning, ma'am.
Good morning.
Started on 18th century. Runch, and he separated inorganic compounds by using filter paper. On 19th century, D.T. Davy, he introduced column chromatography and he separated hydrocarbons from petroleum products. On 20th century, Michael Sweat, he introduced column adsorption chromatography and he isolated plant pigments using calcium carbonate as adsorbent. Martin and Singe, they introduced column partition chromatography and separated chemicals with slight difference in partition coefficient between the liquid solvents. Same on 20th century. And Stahel and Merck introduced ion exchange chromatography and TLC, thin layer chromatography, on 20th century. And the modern 21st century, Kaiser and Patel, they introduced HPLC, high performance liquid chromatography, and HPTLC, and liquid chromatography coupled with mass spectroscopy, also gas chromatography coupled with mass spectroscopy.
Okay, so that's all we have seen regarding history of chromatography in various centuries, how it was developed by whom. Next, we'll move on to the main topic, paper chromatography. So after introduction, classification, and history of chromatography, let's move on to the first part of chromatography, that is paper chromatography. Why it is called as paper chromatography means, since we are using stationary phases paper, that is Wattman filter paper, not normal filter paper, it is the Wattman filter paper. It is highly graded paper meant for chromatographic separation. So that we are using for separation, so that it is called as paper chromatography. Since we are using stationary phases paper mode, then it is called as paper chromatography, where separation occurs to give the colored compound. So that it is called as chromatography, and it is coming under planar chromatography. Under planar and columnar, it is a part of planar chromatography, and it is the basic chromatography meant for qualitative analysis. Whenever you want to perform qualitative analysis just for identification purpose, if you want to perform any separation, then you can prefer paper chromatographic analysis. So what for it is used? Qualitative technique. Okay, it is. And about history of paper chromatography by Martin and Singe, it was invented, and they were two British biochemists. Okay, in 1941, both have worked together to develop paper chromatography, and they have separated proteins which made up of chains of amino acids. Paper means mostly will be preferring separation of amino acids on it. So which sample mostly is developed by paper chromatography? Amino acids. Apart from it, all other compounds also are separated, but it should be, the condition should be, it should be soluble in water. Sample should be soluble in water. So those type of compounds only separated by paper chromatography. Water soluble samples. like amino acids, other samples, whichever is polar and soluble in water, they can be separated by using paper chromatography. Why means since paper comprises of water molecules, we need to perform a separation for water soluble drugs. And let's move on to the paper chromatographic parameters. What are the different parameters to carry out paper chromatographic analysis? First is principle behind paper chromatography. It is the partition chromatography. Partition means it follows partition coefficient principle. That means distribution of sample occurs between two immersible liquids. So liquid and liquid chromatography it is called. Liquid and liquid separates represents stationary phase and mobile phase here. So liquid chromatography, partition chromatography, liquid chromatography, and then planar chromatography where separation occurs over plane surface. Then ascending development technique, mostly will prefer ascending development techniques. That is away from Earth's gravitational force, separation occurs. Against gravitational force, if separation occurs, then it is called ascending development technique. Your sample moves against gravitational force. Okay, this is a common technique in paper chromatography we will be performing. So it is mentioned as ascending development technique. Then one-dimensional development technique. One-dimensional means this principle what I have focused is whatever you are going to perform in practical. So theory comprises both practical things and theory. So we'll discuss practical related parameters also. So it will be helpful when you are performing practicals. Okay. This one-dimensional development technique, since only one direction development occurs, either ascending or descending, your development may occur. So that is that type of technique is called as one-dimensional development technique. On single direction development occurs. Okay. Then how the development occurs based on capillary action. Capillary action. If you see the Whatman filter paper or imagine any filter paper, normal filter paper, it will be having pores in it. Filter paper means fibers. Fibers means it will be made with polymers. Polymers only creates fibers, so they will be having pores. Inside the pores, your mobile phase will be running along with the sample, so that your sample gets separated. So this type of separation is called capillary action, and that pores are acting as capillaries. So through the pores, sample and mobile phase moves and it is getting separated. That principle is representing capillary action. Okay. So these are the kind of principle what we are following under paper chromatographic parameters. So first one is partition chromatography, then liquid chromatography, planar ascending development technique, one-dimensional development technique, and by capillary action, the sample moves for separation. There are different development techniques are there. The most followed technique is ascending development and one-dimensional development technique. The second parameter for chromatography, what we require for separation, one phase is stationary phase, another one is mobile phase. Let's see what is stationary phase used for, stationary phase used for paper chromatographic separation. It is Whatman filter paper number 1 grade. You can observe the picture where the paper is. Okay. It is a white in color, not looking like a normal filter paper, very pure white color paper it is, and it is of various grades are there. Laboratory grade is number 1, like number 1, 2, 3, to up to 20 grades are there based on the density and density of water incorporated inside the paper and thickness of the paper. Based on it, it is means divided into various grades. In that, number 1 grade with the ideal thickness is preferred for laboratory separation purpose. Okay. So what material? What, ma'am?
Ma'am, Jetlin and Joyjon wants to join, it seems, ma'am.
Okay.
Sorry to disturb, ma'am.
So okay. Class poetry.
graphic and rule-based one filter.
Anybody else to join? Only 13 are there. Okay, shall I proceed then?
Thank you.
So second parameter is stationary phase used for paper chromatography. First one we have seen about principle, and we have come across history of paper chromatography. So under paper chromatography we have discussed history and principle behind paper chromatography technique. Now we are seeing about stationary phase used for paper chromatography. The material used is Wortmann filter paper of number 1 grade. What is actually this Wortmann filter paper has? So only it is meant for paper chromatographic separation, right? It has cellulose fibers. What is cellulose? It is polysaccharide. Cellulose is polysaccharide. So it is made with cellulose fibers. The paper is made with cellulose fibers, and these are incorporated with water molecules. Fibers will be having pores, so the paper will be arranged like pores, and it will be incorporated with water molecules. So your paper is not directly stationary phase. The water molecule incorporated inside the cellulose fibers are acting as stationary phase. How these water molecules are attached to the fibers? Through hydrogen bonding. Water molecule has HOH. So this H will be attached to the cellulose. Cellulose is nothing but polymer of glucose. Glucose units, many number of glucose units combined to form cellulose polysaccharide. So it will be getting attached with glucose molecules also are having OH group, right? Polysaccharides. So it will be getting attached through hydrogen bonding. Hence the water molecules can be incorporated inside the Wortmann filter paper, and in this water molecules whatever will be incorporated inside the Wortmann filter paper are acting as stationary phase. So what is the nature of water? It is liquid. So it is the one part, that is stationary phase, liquid, to give partition coefficient principle, partition chromatographic principle. How stationary phase made as liquid? Water molecules are incorporated inside the cellulose fibers of Wortmann filter paper, and with a particular density of water molecule for each grade will be incorporated according to our separation, and according to our sample size it will be increased or decreased. Okay, so we need to choose the grade based on our need. Okay. Then what actual composition of Wortmann filter paper? Cellulose is the main composition. What other composition it has? The chemical composition of Wortmann filter paper, number 1 is, that is laboratory grade Wortmann filter paper, is alpha cellulose. It's not A, it is alpha cellulose. It is of 98 to 99%. So maximum composition is alpha cellulose. So with cellulose it is getting bind water molecules alpha cellulose. So how much percentage it has? Maximum it covers nearly 99%. Wortmann filter paper is made with alpha cellulose. Remaining 0.3 to 1% beta cellulose, and pentosands, that is 0.4 to 0.8%. Then ash point paper means ash content also will be there, and either soluble matters of given percentage. These are only fractions. Main composition is alpha cellulose, where the water molecules are incorporated for separation. So what is your stationary phase in paper chromatography? Water molecules, which are incorporated inside the alpha cellulose fibers through hydrogen bonding. How it is incorporated? Through hydrogen bonding. When your mobile phase takes the sample along the stationary phase, your sample will be distributed in two immiscible liquids. One is aqueous form, that is water form. Another one is your mobile phase. So your stationary phase is now aqueous form, that is water form, right? So mobile phase must must be immiscible form. So we need to choose organic phase, mobile phase. Okay. So what dimension of the paper is needed? The ideal dimension is 10 into 5 centimeter. 10 into 5 centimeter. We can, now, according to the sample size, we can decide the length and width of the paper. Ideal dimensions are apart from 10 into 5 centimeter, 10 into 10, 10 into 20, 20 into 20. There are four standard dimensions are there. If you want to separate 2 or 3 samples, then we can go with 10 into 5 centimeter. Then let's move on to the third part of chromatographic parameters, that is mobile phase used. So what are the two phases? Stationary phase and mobile phase. What is stationary phase now? To get partition principle, it is water molecules incorporated in the Wattman filter paper. That is the liquid. One part is liquid. Liquid is made supported with inert solid. Cellulose fibers will be considered as inert solid. Inert solid means it will not interact with any other sample. So it is supported with water molecules will interact with your sample for separation, where cellulose fibers are inert for your sample. It will not interact with the sample. Okay. So now let's move on to mobile phase. The second phase, movable phase. What will be the nature of mobile phase? Stationary phase is aqueous. Then mobile phase must be organic form. So both should be immiscible in each other. So that what mobile phase we need to choose organic phase. To get organic phase, we need to select organic solvents. What common mobile phase is chosen for separating amino acids? The basic separation was carried out on paper chromatography with amino acids. So general mobile phase for amino acid is N-butanol, glacial acetic acid and water. Here water is the part of mobile phase. So your mobile phase will be having composition of organic phase and aqueous phase. Organic phase and aqueous phase. For separation of your compound, polar molecule also must be there along with organic phase. What is organic phase here? N-butanol and glacial acetic acid. You may use any other solvent also. According to your sample polarity, we can decide any other organic phase also. Already fixed and optimized the organic phases. What?
Join the class, ma'am.
Ma'am, Rupesh wants to join.
I have given. And next is, so we were discussing about mobile phase, that is N-butanol, glacial acetic acid and water. Here N-butanol and glacial acetic acid are considered as organic phase, and this water, that is water, considered as aqueous phase. So mobile phase must be the combination of organic phase and aqueous phase for paper chromatography. Other chromatographies, according to the polarity and the nature of stationary phase, the composition of mobile phase also will be varying. It is only for paper chromatography. What, no? And the ratio is 4:1:5. Please mute your mic. The ratio is 4:1:5 volume of each. Okay, in volumes 4:1:5. According to the order of N-butanol, glacial acetic acid and water. 4 volumes of N-butanol and 1 volume of glacial acetic acid and 5 volumes of water. Why we are using water also in mobile phase means then only your sample will be little bit at least soluble in mobile phase to move fast to separate. So that we need to consider high polar solvents and low polar solvents also to separate your molecules efficiently. That's why this combination is chosen. If you know the polarity and the phase of separation only, we can choose the solvent for mobile phase. So what is the mobile phase composition for paper chromatography? It will be comprising organic phase and aqueous phase. in a mobile phase itself, it will be having organic phase and aqueous phase. What organic phase we are using here? N-butanol and glycolic acid. What is aqueous phase? That is water. Where stationary phase composed water, that is aqueous phase. Next, about what type of mobile phase chamber should be used. For laboratory purpose, you can use 250 ml beaker with petri dish lid. Where for industrial purpose and research purpose, you can use a mobile phase development chamber itself. Okay, a rectangular chamber you can find with the different dimensions according to the paper dimension. If you need to separate your sample with 10 into 5 centimeter dimension paper, then we can choose 10 into 10 size dimension having mobile phase chamber for separation. Likewise, if you increase the paper dimension to 20 into 20, then you may find 20 into 20 chambers also. According to the paper dimension, mobile phase chambers also are there. So we can select the chambers according to the dimension of the paper and size of the samples. And the lid will be either metallic lid or glass lid we can use for closing it. Since we cannot allow air to pass inside, so it will affect the movement of your sample along the stationary phase, so that it should be tightly closed with the lid. For laboratory purpose, we will be using petri dish lid for closing it with a glass beaker. The transparent mobile phase chamber must be used. Then only we can see the colored spots separation. So that. And next point under mobile phase is chamber saturation. What is chamber saturation? Mobile phase chamber must be saturated. How it is saturated with the mobile phase? You can see this lining. This represents the mobile phase volume. So we have to fill your mobile phase chamber up to this nearly 1 centimeter. It may occupy in your mobile phase chamber. So it must be, your mobile phase chamber must be saturated with this mobile phase solvent vapors. Why means, if you are not saturating your mobile phase, it may be you should have washed mostly with distilled water. You will be washing your containers, right, with water. So water particles will be sticking along the your mobile phase chamber. So they will also mix with your mobile phase, and it will interfere in the ratio of mobile phase what we have choose. It will be altering, and so that it will affect the separation of your sample. And the movement also will be affected when it is not saturated properly. When your mobile phase chamber is not saturated properly, your sample movement also will be disturbed. No linear movement or horizontal movement you will be getting. Instead, to get this horizontal movement, it will be like wavy like movement you will get. So this effect is called edge effect. To avoid formation of edge effect, like a curvy form, it will be moving. Either at the center, the solvent will be moving fast, and at the corners, it will be moving slowly. So to avoid this edge effect, we need to saturate the mobile phase chamber completely. Okay, so how long we need to saturate and how it is saturated? Manually you can check whether the chamber is saturated or not by lining a piece of normal filter paper along the sides of the mobile phase chamber. You can keep a normal filter paper along the side, a small piece of normal filter paper, so that it will be getting wet along the paper, so that you can come to know once it reaches the top of mobile phase chamber, it indicates that the chamber is completely saturated. Okay, so likewise we can saturate your mobile phase chamber with mobile phase vapors, or else we can allow the chamber for 20 minutes. Ideally you can keep, after adding mobile phase solvent into the beaker, you can close with the lid and allow it for 20 minutes. It is ideal chamber saturation time. For any chamber you can leave up to 20 minutes, so automatically it will be getting saturated. So before keeping your stationary phase for development inside the mobile phase chamber, we need to saturate the mobile phase chamber with mobile phase solvent. Okay, this is the condition. So first we need to prepare mobile phase with the mentioned composition, that is having both organic and aqueous phase with a selected ratio, and then the selected mobile phase chamber, we need to transfer this composition and it should be allowed for saturation. After saturation only, we need to move for next parameter of chromatographic separation. So till now, what are the parameters we discussed? Principle behind paper chromatographic separation. Then stationary phase, what it is used, actually what stationary phase it is, and now mobile phase. These are the two important parts of chromatographic separation that we have discussed for paper chromatography. Now let's move on to the sample application part. Now you are ready with stationary phase and mobile phase. You have selected Whatman filter paper of preferred dimension and then mobile phase of preferred solvent system, and it is saturated, getting ready for separation. Next, what we have to do, we need to apply sample on the Whatman filter paper. What type of sample we need to choose? Mostly water soluble samples are preferred for paper chromatographic separation. Usually we'll be choosing amino acids for laboratory purpose separation. Amino acids and carbohydrates you will be separating, but according to your syllabus in practical, you will be separating amino acids by using paper chromatography. What is the concentration of sample is 0.1 to 2%. 0.1 to 2% weight by volume solution of amino acid in distilled water. How you will prepare 0.1 to 2% solution? The mentioned number here 2 gram of sample is taken. That weight W indicates a weight of sample. That should be the mentioned numericals. They either 0.1 to 2 gram per volume is what? 100%. It is 100 ml. It is mentioned with percentage weight by volume. So you need to weigh the mentioned amount with 100 ml. You need to dissolve the sample in 100 ml water or whatever solvent you are going to use, so that it is given as 0.1 to 2% weight by volume. So to get percentage solution, we have to dissolve the mentioned amount of sample in 100 ml solvent. So what is the concentration for preparing 0.1 to 2% weight by volume solution? How it is applied over the paper? By using capillary tube or micropipette, the selected volume of sample should be applied over the paper. And before applying, you need to mark. You can see the markings here a baseline. Here you need to mark the sample. It is baseline for mobile phase. Mobile phase should be always below than the baseline where you are going to mark your spot your sample. So to know that, you first measure the mobile phase length in the chamber, and then above that you just leave either 0.5 or 1 centimeter and then mark a baseline, okay, for spotting your sample. Why it should be above the mobile phase means, if it is immersing inside the mobile phase, your sample will get soluble in mobile phase itself. So it will not be getting separated to give individual spots. To avoid this solubility and dissolution of your sample inside the mobile phase, your sample application position should be above the mobile phase baseline. So your baseline for sample should be above at least 0.5 to 1 centimeter above the baseline of mobile phase. Okay. After then, you need to mark leaving the distance. You cannot mark at the edges. Leave equal distance for each sample, and then mark the put a circle with a pencil. You cannot use ink pen or ballpoint pen for marking. You can use pencil. Here, using pencil is mandatory here. Since if you use the ink pen, then it will also getting separated, will give color over the paper. So to avoid that, we need to use pencil only for marking. So mark a circle, and you need to place your sample in that circle by using either capillary tube or micropipette. So a drop of sample from the prepared sample solution, you can take a drop by using capillary tube, or if you use micropipette, you can choose 1 to 5 microliter sample approximately, and you can spot here. Since it is qualitative method, you can no need to measure the exact volume. One drop by capillary tube over the paper, applying over the paper is sufficient for separation. One drop. if you keep more sample, what happens? Why it is only mentioned to 1 drop? If you spot more amount, it will diffuse more. So if you spot 3 or 4 samples in the same plate, same paper, it will be overlapping and you won't get well separated spots. So to avoid overlapping on tailing effect of tailing also will occur. If you spot more sample, you will not get well separated individual spots. Instead you will get all mixed spots with each other. So to avoid that, we need to use minimum very diluted samples of only 1 drop. Okay. Then before keeping it inside the mobile phase chamber, the paper with the sample applied should be dried well. Okay. If it is in wet condition, again when mobile phase moves means along the stationary phase, it will be again soluble and dissolved in the mobile phase. So it won't come for development. So that after spotting your sample, it must be dried thoroughly. Okay, paper must be dried thoroughly, and then you have to keep it for development. These are the conditions of sample preparation and application over the paper stationary phase. Okay, what you have to do, how much concentration you need to prepare, that is 0.1 to 2% weight by volume solution of amino acids or any water soluble substance can be taken of the mentioned amount. Then how you will spot the sample? Before spotting the sample, you need to mark a baseline over the mobile phase baseline. Leave nearly means above, it should be above the mobile phase baseline, and leaving 0.5 centimeter or 1 centimeter. Then you draw a see the length of paper, and then accordingly you can decide the length where you need to mark the baseline. First you mark the baseline, split for space for each spot, and then give a marking with by means of pencil, and then mark or apply your sample by using capillary tube. Okay, if you use capillary tube, 1 drop is sufficient. If you use micropipette, you can measure 1 to 5 microliter, and then you can spot in the required place where you need to spot that particular sample. After then, you need to dry thoroughly the paper before keeping it for development. Then how you will locate the stationary phase inside the mobile phase chamber? That is called positioning of stationary phase. How you will keep the stationary phase inside the mobile phase? By means of, it is they have given a clip, and it is kept for industrial purpose. We can use this for laboratory purpose. So how we can keep your mobile phase or locate your mobile phase inside the stationary phase inside the mobile phase means it is positioned by means of hanging with a thread in the mobile phase after drying well the spots applied. Okay, so after drying the spots, sample spots, whatever you have applied over the baseline which you have marked, then you need to hang the paper. You can fold the paper here with the thread, a big thread, and keep the thread here. Insert your paper inside the mobile phase chamber and close with the lid. It will be hanged inside. And it cannot always, you will be keeping stationary phase inside the mobile phase in the slanting position only, not exact horizontal position. This slanting position will be keeping the stationary phase inside for development. And next parameter is development time. So now you have kept the sample with the stationary phase inside the chamber, and you have closed, and it is allowed for development, right? So mobile phase start moving over the stationary phase now for separation. Since you have applied the sample and dried the sample properly, and now you have located the stationary phase inside the mobile phase. Now mobile phase is ready for separation of dried spots that you have marked over the stationary phase. Now we need to note down how much time we need to allow this for separation, so that your molecules of mixtures will get separated into individual molecules. So how long you need to keep for development? That is called as development time. So you have to note down the time from the baseline up to 3/4 of the paper, how long it takes to move. That is the time called development time. So it is defined as the time taken by the mobile phase solvent along with the samples to reach the solvent front. Solvent front is nothing but the 3/4 of the stationary phase length is called solvent front, where it stops separating. Okay, we can stop separating your sample or a mobile phase movement. We can stop at solvent front. It is nothing but 3/4 distance of the stationary phase. So where also you can put a marking with pencil. So until that, you can, before keeping your stationary phase itself, you can mark with the pencil, leaving 3/4 distance for the separation, or else you can allow free movement of mobile phase. When it reaches 3/4 approximately, you can stop the development until you can take out the paper from the mobile phase chamber, and then you can mark with the pencil of solvent front. Before drying your solvents, you can means mark with your mark with the pencil at solvent front. Since distance is major factor here to identify the sample, that's why we need to note down how much distance it is traveled, solvent, how much it is traveled, and how much time it has taken to travel. 3/4 distance is known as development time. It is also a factor when you are going for analysis, either qualitative or quantitative analysis. For getting reproducibility in your results, you need to mark or note down development time, how long each sample and mobile phase is taking for reaching the 3/4 of the distance. Why means it will also affect with environmental conditions and the vapor, how it is moving. Your mobile phase vapors will be moving with the stationary phase. It will be also affected with environmental factors like air, temperature, and this all. So that we need to note down development time. It may be varying with laboratory to laboratory, person to person, how you are performing the based on how you are performing the experiment. Okay. Then after development is over, after mobile phase moved 3/4 distance, then you have to remove the paper out of this mobile phase, and you need to dry the paper in air only. Okay, no need to heat or something for drying. Just keep it under air for drying the paper completely. We need to after each and every step we need to dry. This is the second step of drying in paper chromatographic analysis. What is the first step where you have dried? After keeping sample, you have dried the spots well. Okay, even single particle of your water or solvent particle is there, it will affect the separation of molecules. So you will not get well separated molecules. Instead, you will be getting a mixture or a tailing effect of that molecule in the paper. You can see the picture how it is well separated molecules with different colors you can observe. But if you are not drying properly, this location of spots with well separated manner is affected. Instead, you will be getting mixed spots. Red, pink, violet color, you can see, blue color. So these all spots will be mixed, and you will get a tailing of all the spots. So you cannot separate and analyze well. For that purpose, we need to dry each and every step. After performing, we need to dry the paper well. How you are receiving the Whatman filter paper before using fresh paper. Likewise, at every step, we need to dry the paper carefully. So this is the development time and drying after development. So what are all the parameters we have seen till now in paper chromatography? Principle of paper chromatography, stationary phase and mobile phase used, sample application, then positioning of stationary phase, then development time, drying after development. So in the next class, we will discuss about deduction and applications of paper chromatography. And different techniques of paper chromatography we'll discuss in the next class. We'll start with this now. Hope you have understood the concepts behind paper chromatography. It is very simple only, but we need to follow all procedures carefully. And it is a major practical you will be doing in your lab. When you are coming here, you will be performing paper chromatographic analysis. Okay. Is there any doubt? You can clarify for your doubts, or else we'll meet in the next class. Tomorrow morning, first hour, we'll meet. No response.
Clear, ma'am.
Clear now? Okay, we'll leave the meeting then. Thank you all.
Thank you,
Go
ma'am.
through and come in the next class.
Baby, baby.
இருமே கிளாஸ் ஓவரா
சும்மா கூப்பிட்டு உனக்கு காது கேக்குதான்னு பாக்க.
இல்ல இல்ல பாப்பா வச்சிருந்தேன்.
எந்த பாப்பாவ?
ஏய் செருப்பு. யார் யார் இருக்கா?
சரி அப்படியே பேசிட்டு இருங்க, கிளாஸ் ரெக்கார்ட் ஆயிட்டு இருக்கு. பேபி நல்லா பாத்துக்க பேபி, டாட்டா.